Watch the complete playlist on the app Pions. Download the app now.
So if you're given with any function, let's say there is a function f of x, okay, and if I take the value of function f of x as x plus 2, let's say, okay, so here the value of function is x plus 2, and if I want to check that our given function is continuous at any value, for example, they ask you find the continuity of the given function at limit x tending to 3, okay. So there are two ways in which you can approach to 3 on the number line. Focus here. If this is the number line, here it is 0, and let's say this is 3. You can approach to 3 from the left hand side of 3 and to 3 from the right hand side of 3. Be very careful. So when you are approaching to 3 on the left hand side, we write it as 3 negative. It's not minus 3. Many people, they are confused with this. This is not minus 3. This is 3 minus. 3 minus means you are approaching to 3 from the left hand side of 3. And limit x tending to 3 plus. 3 plus means you are approaching to 3 from the right hand side of 3. These are the basic notations we will use here. And then we will substitute. Okay. And then we will see if the left hand limit is equal to the right hand limit. If the left hand limit is equals to the right hand limit, then we say that the given function is continuous. Clear? So here you will see the continuity part of limits which we have done. Okay, limits we have already done in 11th standard. Here we have continuity in class 12th. So if the left hand limit is equal to right hand limit, we call such a function as continuous function. Clear? If you substitute a number on the left hand side of a given value, that is negative here, 3 to the 3 here negative, and this is 3 positive. Again I am repeating, this is not minus 3. It's a number on the left hand side of 3 in the neighborhood of 3, like 2.999999. 3 plus means on the right hand side of 3, 3.00001. Okay, that's our limit. So we will talk about this thing more later, since these are revision. So we have already done. Okay, let's go directly to our first problem. So our first question says find the values of a and b if the function f of x is given by this. You have to find the value of a and b if the given function is given by this is continuous in 0 to pi. Okay, so we will break down this. I'll give the core concept in this first problem, how to proceed, and as we will move on to upcoming problems, the concept will become more and more clearer, right? So let's see first, let's talk about this thing. This is very important part of our limits. So look at the first one. The first one is 0 to pi by 4. 0 to pi by 4 means x must be greater than 0 and x must be less than pi by 4. In case if you are not familiar with pi by 4, 45 degree. So x 0 to pi by 4 means you are taking the numbers are from 0 to pi by 4. Now when you say x is greater than 0, x is greater than 0 and here x is less than pi by 4. Pi by 4 we were talking about, pi by 4 is 45 degree. So which means you can take any value between 0 to 45. 0 to 45 degree, any value of your choice. Clear? So this x is less than 45. Less than 45 means, sir, left hand side of pi by 4. Left hand side of pi by 4 means this is left hand limit of pi by 4. Correct? Left hand limit of pi by 4, x less than pi by 4. While if you look at the second one here x is greater than pi by 4. So this is a right hand limit of pi by 4. Next, x less than pi by 2, left hand limit of pi by 2. And here x greater than pi by 2, right hand limit of pi by 2. X less than pi, left hand limit of pi. Let me take a fast recap of what we have done just now. So let me just remove this and let me just repeat what we have discussed. X is less than pi by 4, which means left hand limit of pi by 4. X is greater than 0, which means right hand limit of 0. So this whole thing gives us two information. One information is RHL for 0, right hand limit for 0, left hand limit for pi by 4. This information we can extract here. Next one, RHL, right hand limit for pi by 4 and left hand limit for pi by 2. Next information from the third one, RHL for pi by 2, right hand limit for pi by 2 and left hand limit for pi. These are our limits. Now which limits you have to consider while solving the problem? Listen very carefully, because the whole game is about limits here. Whole game is of this right hand side part here. So be very careful. First you should be clear with how to go through these. Then we will come to the function and we will talk about how to figure out values of A and B. So here I hope this is clear. RHL is for 0, but there is no LHL for 0. Correct? Can you find LHL for 0? No. LHL for pi by 4, RHL for pi by 4. So they can be, we can check it over here. Left hand limit for pi by 2, right hand limit for pi by 2. We can check it over here also. But there is no RHL for pi. No RHL. So sir, what to do for 0 and pi? You have to ignore them. Because, why to ignore? Because you can't find the value of function on the other part. To check if the given function is continuous on 0 or pi, you need both left hand limit as well as right hand limit. If left hand limit and right hand limit is not given for a particular value, you will not consider it. Clear it is? So 0 will not be considered, pi will not be considered because the limits are not properly given. I hope this is clear. So when we will solve it, you will find that sir is solving only for pi by 4 and pi by 2. You should not get surprised that why 0 and pi is ignored, even though it is clearly mentioned here that the function is continuous for 0 to pi. Let's start solving here with pi by 4. So at pi by 4, let me solve this at pi by 4. First of all, left hand limit. So limit x tending to pi by 4 minus function of x. Pi by 4 minus means on the left hand side of pi by 4. LHL of pi by 4, that is pi by 4 minus. Now what you will do? Now you will call the function. What is the corresponding function for left hand limit? This one. So if this is the corresponding function, we can rewrite it as limit x tending to pi by 4 negative x plus a root 2 sin x. I hope this is clear. Now what you will do? You will place in place of x pi by 4. You have to substitute the same thing. So when you substitute pi by 4, it will be pi by 4 plus a root 2 into sin pi by 4. Sir, what is sin pi by 4? Sin pi by 4 is 1 by root 2. The value of sin pi by 4 is 1 by root 2. So this will be pi by 4 plus a root 2 into 1 by root 2. Let's cancel out this with this. So left hand limit, I am writing here LHL. Okay, this is our left hand limit. So left hand limit, what we got? We got LHL as, for the given value as a plus pi by 4. Equation number 1. Let's figure out RHL at pi by 4. So right hand limit will be limit x tending to pi by 4 positive f of x. Now for x tending to pi by 4 positive, this will be called, I have already explained this, and corresponding to this, it is corresponding to this, which function it is? This one. So it will call that function. So limit x tending to pi by 4 plus f of x is 2x cot x plus b. Let's substitute the values. So 2 into pi by 4 cot pi by 4. We simply substitute in place of x because this is a function of x. So these are the values of x you can see. So pi by 4 into this will be pi by 2 cot pi by 4, cot 45 degree 1. So pi by 2 plus b. This is our equation 2. Now from 1 and 2, LHL must be equal to RHL. So if left hand limit is equal to right hand limit, this will be a plus pi by 4 will be equals to pi by 2 plus b. Let's take b on the left hand side. a minus b equal to pi by 2 minus pi by 4. 90 minus 45. 45. Equation number 3. We will make use of it while solving the other half of the problem. Clear? So this is our first equation we got. Still it is not solved yet. We have to solve for pi by 2. Okay, that will give us a second equation, and that we will solve simultaneously. Clear? So what is our function here? Our function is this for left hand limit of pi by 2. So let's put here. Okay, let's solve it on another page. So that will be 2x cot x plus b. So it is 2x cot x plus b. This is our function for LHL. Okay, this is our function for LHL. And what is our function for RHL? A cos 2x minus b sin x. A cos 2x minus b sin x. This is our RHL function. This is for x less than pi by 2 and this is x greater than pi by 2. So let's write here at x equal to pi by 2. Let's put here LHL. LHL. So for LHL, limit x tending to pi by 2, how do we write the left hand limit? Minus f of x. So this will be limit x tending to pi by 2 minus, what is the function? Which function is called? This function. So it will be 2x cot x plus b. Now what is cot pi by 2? Sir, tan pi by 2 is not defined. So opposite of not defined, 0. So cot pi by 2 is 0. So here you left with 0 plus b. Equation number 4. Okay. This is our LHL, left hand limit. Let's simplify for RHL. So RHL, I am solving here. RHL is limit x tending to pi by 2 positive f of x. Which function is called? Our function is called as limit x tending to pi by 2 plus a cos 2x minus b sin x. Now when you put the limit, let's see what we get. A cos 2 into pi by 2 minus b sin pi by 2. 2 and 2 cancels. You left with a cos pi minus sin 90 is 1, so b. Cos pi, cos 180 is minus 1, so minus a minus b. This is your RHL. If a function is continuous, then its left hand limit should be equal to right hand limit. So from 4 and 5, b must be equal to minus a minus b. So 2b is equals to minus a. Very important outcome. Let's go back and see what was our first equation. Look at equation 3 here. Let me put it in a box. A minus b is pi by 4. Let's use it. So a minus b is pi by 4. And from here 2b equal to minus a. So let's put here a as minus 2b. So minus 2b minus b equal to pi by 4. And minus 2b and minus b, that will be minus 3b equals to pi by 4. And this implies b equal to minus pi by 12. If b is minus pi by 12, let's put it here. So b is minus pi by 12. So this will be, a will be minus 2b. So minus minus plus pi by 6. These are the values of a and b which satisfies the given function is continuous over 0 to pi. Let's move to question number 2. Okay. So again I am repeating, formulas are very important. So you should know all the identities are available on the app. Okay. So let's start with our question 2. Find the values of constant a and b if the function is continuous at x equal to 0. Beautiful problem. Here you are given with 3 numbers, okay, 3 different x greater than 0, x equal to 0 and x less than 0. Okay, so when you are choosing a number line, okay, this is 0, any number on the right hand side 0, right hand limit, any number on the left hand side, left hand limit, and 0 itself, when you are putting, it is central limit. Whenever central limit is given, listen very carefully, then all three should be equal. Then only the function is continuous. Even if central limit is not given, like in the previous question, fine it is. If LHL is equal to RHL, we assume that it is continuous. So if central limit, like here it is given x equal to 0, central limit is given, then this must be equal to this and this must be equal to this, or all of them must be equal. Clear? So let's proceed in a similar fashion. Our left hand limit, let me write here. So left hand limit will be limit. How do we write it? As x tending to whatever value here it is given, 0 and negative. So which one is 0 negative? Be very careful. This one is 0 negative. This one is 0 positive. Clear it is? So that is our left hand limit. So let's call our function f of x. Let's put here function. So limit x tending to 0 negative. What is f of x? Log of 2 plus x minus log of 2 minus x whole divided by x. Okay. Sir, can we directly use the identity? Be very careful. The identity, if you check in the formula sheet, it is 1 plus kx upon x. Or you will have log of 1 plus x upon x. Something like this. You don't have 2 in the identity. So somehow, first thing is simplification. You have to somehow simplify this log 2 plus x and 2 minus x in a simpler format. To do that, first let's separate them. So limit x tending to 0 negative log of 2 plus x whole divided by x minus log of 2 minus x whole divided by x. Clear? Now what I'll do? Now be very careful. I'll take log here 2 common out inside the log, and I will write it as log of, pay attention, 2 into 1 plus x by 2. I can write this. If you have confusion like how sir you got this, simply multiply this 2 with 1, you will get this 2. Multiply this 2 with x by 2. 2 and 2 cancels and you left with x. Similarly, in the second expression, let's take 2 common out. It will be 1 minus x upon 2 whole divided by x. I hope this is clear. Now we will make use of very famous identity, log of a into b. Two numbers are multiplied here, then it will be simply log of a plus log of b. So let's use this identity over here and write it here, limit x tending to 0 negative log of 2 plus log of 1 plus x by 2. Now whole divided by x minus log of 2, I am keeping a bracket to avoid mistakes, plus log 1 minus x by 2 whole divided by x. Let's separate them. Limit x tending to 0 negative log of 2 divided by x plus log of, now I am just rewriting this as 1 plus half into x. X by 2 is half into x whole divided by x minus log of 2 divided by x, and plus minus, be very careful with the signs, 1 minus half x divided by x. This will straight away cancel with this, because log 2 by x and log 2 by x cancels out. And what you left with, let's see. So limit x tending to 0 negative log of 1 plus half x upon x minus log of, let's keep a huge bracket, 1 minus half x upon x. Now limit, in case if you are not familiar with this identity, I am writing here limit log of 1 plus kx upon x will give you straight away k, provided here x must be tending to 0. If x is not tending to 0, it will not give you k. Okay, in that case you have to simplify somehow. So here I am simplifying and we already have 0, so we will straight away get half from the, because if I compare, k must be here half, And here what is the value of k? Minus half. So minus half. So half and half, 1. This is our left hand limit. And this left hand limit, this is LHL. LHL we got as 1. This must be equal to the central limit, which is b. So b's value is 1. We got it. The value of a we will get it from our right hand limit. Clear? So let's move to RHL. Let me simply first write the function. Okay. So on the page, it will be root under 1 plus x minus sine ax. Let me scroll up. 1 plus x minus 1 it is. 1 plus x minus 1 minus sine ax. No, into sine x. Into sine x. Whole divided by 10x whole square. 10x whole square. Let's just last time reconfirm. 1 plus x minus 1 sine ax upon 10x whole square. Limit extending to 0. This is for our x greater than 0. Let's simplify it. So taking RHL now. RHL, limit x tending to 0 positive. And let's put here root under 1 plus x minus 1 whole into sine ax divided by 10x whole square. Now focus how to simplify. If I directly put here, sir, why don't you directly put? Let's directly put. Okay, and this thing I should tell at the beginning, but now again I am repeating this. If I put directly x as 0, the things will reduce to 0 in the numerator as well as 0 in the denominator. Let's see, if x is 0 here, tan 0 is 0, so denominator becomes 0. And here putting x as 0, 1 plus 0 is 1, 1 root is 1, 1 minus 1 is 0, 0 into 0, 0. So you are getting undetermined form, which is 0 by 0. Your answer can never be 0 by 0. So what you have to do, you have to simplify. How do we simplify roots? Focus here. So what I will do here is, I'll rationalize it. Whenever I don't have any other trick, I rationalize. That becomes quite easy to simplify. Clear? And we will make use of two formulas. Limit x tending to 0. Be very careful. Only for 0 it is true. Sin x upon x is equals to 1. And limit x tending to 0. Tan x upon x is 1. So let's simplify further. First of all, let's multiply this bracket with our first one bracket. So it will become limit x tending to 0. A minus b into a plus b. A square minus b square. So 1 plus x minus 1. Let me repeat again. A minus b, a plus b. A square minus b square. So when you a square it, your root will go, and when you square b, 1 will remain 1. So you got this. Sin ax whole divided by, I am just writing this 10x whole square as 10x into 10x just to make it simple for you. Done. 1 cancels with this minus 1. I have not substituted any limit again. Still, if I put x as 0, everything will reduce to 0. So be very careful. Still further I have to simplify. I am dividing with ax, multiplying with ax. I am dividing with x, multiplying with x. I am dividing with x, multiplying with x. Now 10x upon x is 1. 10x upon x is 1. Sin theta upon theta is also 1 for x tending to 0. But we can't substitute. If we substitute, still we have these x sitting in front. So let's simplify further and rewrite this expression as limit x tending to 0. This x and this ax, when they multiply together, you get ax square. Let's keep this sin ax upon ax as it is. Whole divided by this x and this x will make it x square. And let's write it here as 10x upon x into 10x upon x. X square cancels with x square. So we missed this root under 1 plus x plus 1. So let me write it over here. 1 upon root under 1 plus x plus 1. Now when you substitute here, so this will give us how much? This will be 1, 1, 1, a into 1 upon, putting x 0, root of 1 is 1, 1 plus 1 is 2. You got a by 2. Now putting equal to the central limit or the left hand limit, which is 1, this gives us a equal to 2. So be very careful with these things. Okay, let's move to question number 3. Question 3 now says check the continuity of the following function. So here you don't have to find something, you have to simply see if the left hand limit is equal to the right hand limit or equal to the central limit. All limits are equal, then it is continuous. So let's start with our first one. Okay, so let's start with our left hand limit. So left hand, one second. Okay, left hand limit here is x less than 0. This is our left hand limit. So limit x tending to 0 negative f of x. F of x is sine 3x upon 10 2x. Correct? Now what I'll do, I'll just separate them and rationalize them. So limit x tending to 0 negative sine 3x upon 3x into 3x. Correct? Into 1 upon 10 2x. 10 2x can be written as 10 2x upon 2x into 2x. Correct? Now let's cancel this x with this x and let's put this up now limit. So putting the limit, this will be 1, and putting limit over here, this will be 1. What we left with? 3 by 2. So the answer on the left hand limit is 3 by 2. Is it equal to central limit? Yes. So can we say directly that it is continuous? No. First we have to check the right hand limit also. So let's see the right hand limit. So RHL will be limit x tending to 0 positive. Be very careful, sir. What if I don't write 0 positive? They'll cut your marks in exams. Sir, what if I simply write only limit in the first step and I'm not writing limits in every step? Then they'll cut your marks. Be very careful with this. You have to write limit in each step until you are substituting it. So this will be log 1 plus 3x whole divided by e to the power 2x minus 1. Let's simplify it further. Be very careful. Limit x tending to 0 plus. So log, be very careful what I am doing. Rationalizing again. Whole divided by x into x. Correct? And here I am just rewriting it as 1 upon e to the power 2x minus 1 upon x into x. Clear it is? I just wrote it separately and I rationalized it. If you cancel all the x, you will come back to this actual function. Now let's cancel this x with this x and put the limits. So putting the limit, let me remind you the identity. Limit x tending to 0 log of 1 plus kx upon x, that is nothing but k. Limit x tending to 0 e to the power kx minus 1 upon x is k. Let's substitute here. So here we will get k, which is 3, and here we will get k as 2. So this is our RHL. So our left hand limit equal to right hand limit equal to central limit. Hence, since left hand limit is equal to right hand limit and central limit, hence the function is continuous at what point? X equals to 0. Be very careful. Not on every point. At x equal to 0, this function is continuous. Okay. Our next question is over here. The question says if the function f of x is continuous at x equal to 0, it's given it's continuous, Then find the value of a and b. Then we have to simply figure out the value of a and b if it is already continuous. So we will follow the same method. This is our right hand limit, this is our left hand limit, and this is our central limit. So let me just write it in front of them so that it becomes easy for you to understand. This is our x is less than 0, left hand limit, x is greater than 0, RHL, and this is our central limit. Let's start with left hand limit. So left hand limit we will start, it will be limit x tending to 0 negative function. Which function it will call? b into 1 minus cos 2x whole divided by x square. Be very careful, if it is 1 minus cos 2x divided by x, then you have to worry a little, okay. If it is x square, direct guess is half angle formula, direct. So it will be b into 1 minus cos 2x, 2 sin square x whole divided by x square. If you will directly put x as 0, what will happen? It will give you 0 by 0, which is undetermined form. Now let's write it as b into 2 sin x by x, just to make it simple for you, into sin x by x, correct? Because some teachers directly write it as 1 and then students think that how it got 1. Now I hope this is clear how it got 1. Now sin x by x is 1, 1. So it will be giving you 2b. This is our outcome for left hand limit, correct? LHL. Let's go into RHL, okay? And before that, let's move to CL only directly. CL is quite easy, so let's not waste time. Limit x tending to 0. Some students have this confusion, sir, what should I put? Sign, negative, positive? For central limit, it is no sign. It is simply x is 0. X square minus 1 upon x square plus 1. If I put here x as 0, it will be minus 1 upon 1, which is minus 1. This is our central limit, done. So we have LHL. Our central limit is this. Let's find the value of b. So 2b must be equal to minus 1. The left hand limit must be equal to the central limit. So b will be equals to minus half. This is our value of b. Let's now solve for RHL. So for RHL, this is e to the power minus x plus e to the power x minus 2 upon x square plus a. Correct? This is our function and limit is x tending to 0 positive. Clear? So what to do, sir? If I put here e to the power 0, e to the power 0 is 1 plus 1, 2, 2 minus 2, 0 upon 0 you will get. So sir, next what should I do? Now you can do one thing. If you take here e to the power x common, okay. If we take e to the power x common, but no need of taking common, okay. Here you can do directly also. So let's write it as e to the power x, correct, and plus e to the power minus x whole square. Yes, we can do that. So if you do whole square, it will give you what? E to the, but 2x will give, no, then you will have to take common. So let's remove this and let's take e to the power x common out. What we left with? E to the power minus 2x. I'll explain how we got that. Plus 1 and minus 2 e to the power minus x whole divided by x square plus a. Now you will think, sir, how you took this part common? So if you are thinking like that, focus here. E to the power something and e to the power something. When you multiply both, the powers will add up. So when you multiply this with this, will you get e to the power minus x? Yes. E to the power x, x minus 2x is minus x, right? So you are getting e to the power minus x, which is the first term over here. Now e to the power x multiplied with 1, this will give you e to the power x, correct? And e to the power x multiplied with e to the power minus x. So x minus x e to the power 0. And anything to the power 0 is 1. So you left with minus 2 only in this part. I hope this is clear. Now limit x tending to 0 plus e to the power x. Now that is our whole square of what? E to the power minus x plus 1 whole square. Plus 1? No, minus 1 whole square. Let's check again. E to the power minus x minus 1 whole square when you expand it, e to the power minus 2x, which is this, plus 1, which is this, minus 2ab, which is minus 2 e to power minus x. That's correct. Whole divided by x square plus a. Let's rewrite this as limit x tending to 0 positive e to the power x outside. Can I write it as e to the power minus x minus 1 whole divided by x whole square plus a. Clear? Now next is what? When you put the limit, now focus, e to the power 0, what will you get? 1. X is putting 0 here, 1. E to the power, now here I am using this identity, limit x tending to 0, e to the power kx minus 1 upon x is k. So what is our k here? Minus 1. So e to the power minus 1x minus 1 upon x, it will give us minus 1, and minus 1 ka whole square will be plus 1. So plus 1 you will get from here, plus a. Let me repeat this step again. E to the power 0, this whole thing became 1. E to the power minus kx minus 1 upon x will give you k. K is here how much? K is minus 1, and minus 1 whole square is plus 1. So 1 plus a directly. Now this should be equal to whom? Central limit. Let's put it equal to central limit minus 1. And this gives us a equal to how much? Minus 2. So in this problem, a is minus 2 and b is minus half.
Watch the complete playlist on the app Pions. Download the app now.